Now let's look at differentiation of products of functions. Well, we're going to see what we can do when we are differentiating two functions in respect to x. Now, first, let's look at what we call standard derivative. Now, please remember this because you're going to need it when you differentiate functions. Now, the first one is this. If y is equal to sine x, what is the y dx? The y dx will be cos x. And let this be number 2. If y is equal to cos x, what will be the y dx? The y dx will be minus sine x. What if you have number 3 exponential function, y is equals to e raised to power x? What will be the y dx? The y dx will still be e raised to power x. Now, having established this standard derivative, let's go ahead to see what we can do when we are differentiating products of functions. Now, let's assume that we'll have y is equals to uv. Now, in this case, u and v are functions of x. If I'm to differentiate these, the y dx, what will I have? Now, please pay attention to this. Again, it's going to be a guiding principle when we're differentiating product of functions. Now, y is equals to uv, and I said that u and v are functions of x. If I'm going to differentiate this is what I'll do. Keep the u constant and differentiate v. Then plus product rule, you keep the v constant and differentiate u. That is how to differentiate the product of two functions. This is what will be guiding us as we differentiate functions involving two products. Now let's look at an example. Example 1. If you have y is equal to x squared sine x. Now find the y dx. What will be the y dx? Can you still remember the guiding principle? Here we have two functions. X squared is one function, sine x is another function. So here we're going to keep, let's say the x squared is the u and the sine x is the v. So here we are going to keep the x squared constant and differentiate sine x. Remember, when we differentiate sine x under the standard derivative, what did we get? We got cos x. Then product rule plus, and this time around you keep it sine x constant, and then you differentiate x squared. And if you differentiate x squared, you have 2x. That is the answer to the question. You can take a step further by factorizing this. If you check these two terms, the highest common factor is x. So this can be x cos x plus 2 sine x. Let's go to number 2. Y is equal to x cubed cos x. Now find the y dx. The same procedure, the y dx. Keep x cubed constant. Differentiate cos x. Remember, if you differentiate cos x, it's minus sine x. The minus will be here, and then your sine x. Please do not make the mistake of putting the minus at the front of x cubed. If not, it's going to look like something like this, x cubed minus sine x, and that's already wrong in what you're doing. So rather put it at the back. So it becomes minus x cubed sine x plus, you keep cos constant, cos x, and differentiate x cubed, and that would be 3x squared. I can rearrange my equation to be 3x squared cos x, because the minus is here, minus x cubed sine x. Now the work is neater now, right? You can also factorize. Highest common factor is x squared. So this is 3 cos x minus x sine x. So with this, you could see that the work is more presentable. Easy peasy, like some people would say. Now let's go to number 3. Number 3, I have y equals to x raised to power 4, and then the exponential function. So what will be the y dx? Stay the same principle. Keep x raised to power 4 constant, differentiate ax. Remember, under the standard derivative, if you differentiate e raised to power x or exponential function, it gives you back what you have there. Plus, you keep the exponential function constant, differentiate x raised to power 4, and that's 4x raised to power 3. Now, if you check this, there's highest common factor, so you can factorize. The highest common factor here is x cubed exponential function. You open the bracket, and here you're left with x plus 4. So that's the working. Let's go to number 4. This will be the last example. In this last example, I have y equal to 5x raised to power 3 sine x. And the question asks me to differentiate this product of two functions. The y, the x will be keep 5x cubed constant, and then differentiate sine x. If you differentiate sine x, that will give you cos x plus, then you keep sine x constant and differentiate 5x raised to power 3. And that will be 3 times 5, 15, x raised to power 2. Now, if you check this out, you notice that it's possible for you to also factorize. And if you do, highest common factor is 5x squared. So this will be x cos x plus 3 sine x. That is the solution to the question. So differentiating product of two functions is not as difficult as you may think. But I will want you to do this for me. Let this be exercise. Number 1, differentiate the following. Just see what you're going to get. Number 1, I have 2x x squared cos x. Number two, I have 4x cubed sin x. And number three, hmm, this is, oh, y equal to, sorry, y equal to, so that you don't get confused, exponential function with sine function, with a trig function rather. So these are the questions. The first one is y equals to 2x squared cos x. The second one is y equals to 4x cubed sin x. And the third one, y equals to exponential function sine x. So when you finish working this out, put your answer in the comment section. Let's see who will be the first to get the three answers correctly.